Hello guys, my topic for today is all about the wave of nature matter, quantum mechanics, and the quantum numbers. Nature matter is all about particles whether massless like proton or having mass like electrons. The wave of nature matter is also the central part of theory quantum mechanics, being an example of wave-particle duality. All matter exhibits wave-like behavior. For example, a beam of electrons can be deflected just like a beam of light or a water wave. In a wave of nature matter, we have the de Broglie wavelength. The wavelength of a particle indicates the length of scale at which wave-like properties are important for that particle. Here the de Broglie wavelength. This one h is the Planck constant, m is the mass of the particles, and v represents the speed of particles. Here the formula. So this is the Planck's constant, which is the 6.626 times 10 to the 34, and the mass, which is the 9.1 times 10 to the 31, and the speed, which is the 2 times 106 ms1. A calculation here guys. So this is the Planck's constant, which is the 6.626 times 10 to the 34. It should be 34. So that's the Planck's constant. So Planck's constant divided to the mass, I mean the speed, times the mass. So the de Broglie wavelength, which is 0.364 times 109 m. And now we proceed to quantum mechanics. Quantum mechanics is the behavior of the very small particles like atoms, molecules, and subatomic particles. Quantum mechanics explains on how the universe works at a scale of smaller atoms. We have here the quantum leap. An orbiting electron jumps between energy levels. We have the two atoms fits here. This atom creates a proton when an electron moves to a lower energy level and absorbs a proton. When an electron moves to a higher energy level or leaves atom. So this example is called ionization. The last topic is the quantum numbers. Quantum numbers that tells the address of electron inside an atom. First guys, we have 4 quantum numbers, which is the principal quantum numbers, the angular momentum quantum numbers, magnetic quantum numbers, and the last, the spin quantum numbers. Principal quantum numbers represent the principle of energy level or shell, which electron revolves around the nucleus. It is denoted by the letter n, and it has an integral values, which is the 1, 2, 3, and 4, and so on, except the 0. This number represents the energy level. So this is the energy level 1, level 2, and energy level 3. Next is the angular momentum quantum number. This quantum number describes the shape of subshell within energy level. So now we have here the value of L, which is 0, 1, 2, 3, 4, and so on. And the letter designations is P, D, F, G, and so on. Here we have the value of L, the sub-level, and the orbital shape. So the 0 represents S, which is the orbital shape is spherical. So the shape is here. This is the spherical shape. We have here the letter designation and the value, which is the 0. 1, which is the P, the principal, and the orbital shape is the dumbbell shape. Here is the spherical shape, orbital shape. So is the dumbbell shape, which has the letter designation of P and a value of 1. We have the value of 2 and letter designation of D, which is the diffuse, and the orbital shape is clover leaf. So this is the orbital shape of the D designation letter and the value of 2. And the last is the value of 3 and has the letter designation of F, which is the fundamental. Orbital shape is called 2 complex. So this is the orbital shape, the letter designation and the value of 3. Quantum number is the magnetic quantum numbers. This number describes the energy levels available within a subshell and yields the projection of orbit angular momentum along the axis. Here the number of orbits and the value of ml. So the value of 0 and the piece of orbital is only 1. So the number of the orbital is 1, which have a 3 piece of orbital, 1, 0, and the negative 1. Here the numbers of orbitals, which is 2, and have a value of 5 piece of orbital, 1, 2, 0, negative 1, and negative 2. Is the last number of orbital is 3, which has a 7 orbital pieces, 1, 2, 3, 0, negative 1, negative 2, and the negative 3.